the first Unit 1, Introduction to Image Formatting and Processing. So in this particular unit, we are going to learn how an image is formed, what are the different ways with which we can transform the image, how mathematical equations can be framed out of an image. Okay? Computer Vision Unit 1, Introduction to Image Processing and Image Formation and Processing. So in this unit, we are going to begin studying from how an image is formed. So this unit 1, the first topic what you are going to study is geometric primitives and transformations. In this particular topic, what we'll be studying is we'll be studying the basics of image formation, basics of geometric primitives, and geometric transformations. So by geometric primitives, what I mean is that we are going to see the fundamentals of geometry, basics of geometry, what is a line, point, plane, 2D plane, 3D plane, and so on. In my first introductory class, I told you that we have an image. An image has multiple dimensions. It can have a depth. See, in an image, you can see that so first point, geometric primitives means introduction to the equations of lines, mathematical representations of lines, points, 3D space and 2D space, and so on. Next, we'll see about the transformation. See, what are the common operations that you do with a image? You rotate the image, you skew the image, you make some changes, right? You convert a color image to a grayscale image, and so on. Have you ever thought how your computer performs these kinds of transformations? So in this class, I'll give you a basic introduction about what are these primitives and what are the possible transformations that come out of this. Okay, but only in the coming classes, I will be telling you how to perform these transformations. Quite simple. You generate a matrix, you change the values of the matrix, everything else is changed, right? Once you convert it into a mathematical equation, everything gets easily changed, right? So transformation means how you are going to transform an image. What are the different kinds of changes you can do with a particular image? That is meant by transformation. Primitives means what are the basic dimensions? What are the possible uh, parts of an image? Not exactly parts or components, but something like what are the probable geometric shapes that could be available within an image. Is that okay with all of you? Any questions? Are you all able to understand? So what basically is an image for a computer? In my introductory class, I already told you. See, you can see an image here. And you can see on the left side you have an image. On the right side you can see a matrix. You can see the values are 255, 250 something. Where there is a change in intensity of the pixel, there is a change in the value, right? All the others remain white. Pure white stands for 255. So from 0 to 255, we scaled out this image, and every pixel point in the image is given an intensity value, and based on this intensity value, a grid or a matrix is being constructed out of an image. Is that clear? So this is the mathematical representation of an image, and this mathematical representation is what your computer sees whenever it sees an image. When you see an image, you will find out a lot of other meanings, but when a computer sees an image, it will have a definition for its intensity at each pixel point. So this is how a computer can understand what an image is. Okay, is that okay? So all these things, whatever we see, we have points, planes, lines, shapes, and so on. And the most interesting, most beautiful aspect of mathematics is that every shape can be represented in terms of mathematical equations. While you were studying engineering mathematics, at least some of you have wondered, why should I study mathematics? Why so much of things are there? Here you can see that whether it is an ellipse, parabola, circle, line, plane, or whatever it is, everything has a mathematical equation. And we can transform this image only with mathematical equations. Am I right? So consider a plane, a point, saying take it as x comma y. A point in a two-dimensional space can be represented in terms of x and y. A point x comma y. Two-coordinate system, what you might have studied in your basic geometry. Okay. So how do you represent a line? How do you represent a line? A line has 2 points, right? Two or multiple points. The basic equation what we have been writing is y is equal to mx plus c, right? Mx plus c, and this is the slope. You have a slope, you substitute values for x, you get y, and you get a linear equation. So a line can be represented with the help of homogeneous coordinates, and in computer vision we'll be using a nomenclature where we have a projected face also. Okay, so here a and b are some constant values, and you have a linear equation that represents a line. Ax plus by plus c is equal to 0. So basics of 2D is done. We'll be having different kinds of, say we'll be having quadratic equations. As I told you, we'll be having ellipses, parabolas, and so on. So many kinds of different equations, and these equations will be used to transform these images. Okay. So coming to 3D, like 2D, what we have another one more. Height is also. Suppose I wanted to find out the mathematical space at which this particular point of chalk is there. It is not enough that I have this x and y direction alone. I also need the height also. Okay, so that I get the complete information about the object. See, when I was studying robotics, one of the most important things what we came to know was about how this axis is rotated, how to find out the space, how to, these are all highly related to kinematics and so on. So if you wanted to identify an object at a particular thing in a 3D space, you need to know its 3D coordinates. You need to know the length or the height of this particular, say suppose if it is this chalk piece, you need to know from this point, the distance and all those things. Right? So basically, in our primitives, what we'll be studying is how to represent certain points, planes, objects in 3D. Okay, so here, like what we have seen in the previous example for 2D, in 3D, points will be having X, Y, and Z, three coordinates, and each point will be represented like this. So this is the equation for a 3D line. Okay, is that okay with you? Any questions? We are just studying the basics. Okay, as we go on, we'll study in depth about what we'll be doing in stage by stage. So now, after we have seen 3D line and 3D point, 3D line and 3D points, we'll be looking into what is a 3D plane, right? Similar to a point, when you have a plane, you will have the height, you will have the angle of rotation. If suppose this is a plane, you have this in this angle, you have points here, right? So you'll have three values, that is x, y, and z. Okay, 3D plane can also be represented as homogeneous coordinates a, b, c, and d. So where n is this normal to the plane. Normal is a perpendicular line from the plane to the origin. D is the distance from the origin to the plane. This distance. So in that case, a 3D plane is represented by x vector. See, all these things we'll be considering in terms of vectors. Okay, vectors because we have the direction also. All the three sides we have, right? 2D plane will be representing, 2D point will be representing in terms of vectors x and y as a column vector like this, right? X is equal to x, y. This is a column vector. Okay? Is that clear? So we have this corresponding plane equation also. This is how a 3D plane is represented. So like this we have conics, we have cylinders, we have infinite number of shapes. All these shapes have its own mathematical equations, and based on these mathematical equations, we will be defining the geometric primitives for a particular object in an image and so on, right? As we go on, next is important point and very important things. What are the possible transformations? What are the possible changes that you need to do with an image? What is meant by translation, Euclidean, similarity, affine, and projective transformations? Transformations means you are changing that particular image from one form to the other. Transform. Okay. Form means its shape. one form to other. So you are changing its form from one type of image to the other. So these are the basic transformations that you need to study. Okay, the first one is translation, Euclidean, similarity, affine, and projective. So mathematically, I've given this translation, rigid or Euclidean, similarity, affine, and projective. So all these things will be having different degree of freedom. See, degree of freedom means, what is meant by degree of freedom? You are having a car. Example I'll give you, just listen to me very carefully. Car can move only in two directions, right? You cannot move a car in the side direction. Can you do it? So its degree of freedom is 2. It can either go forward or it can come backward. You cannot move in the sidewards direction, right? But when you are standing, you can move in any direction you like. You can move this side, you can move this side, any side you can, right? Yes or no? So degree of freedom is the capability of an object to move in different angles. That number of angles is important. So keep this point in mind. All those people who are having car or bike, whatever you can take, even if it is a cycle, it can move only in forward or reverse direction. It cannot move sideways, right? So you have 2 degrees of freedom. The number of times an angle can be changed. You cannot move your hand behind this, right? This is a maximum way in which you can move your hand, right? So how much degrees of freedom does your hand have? Your elbow hand. This is different. This you can rotate it in all angles, right? This angle is different from this one because this you can't move in every angle, but this can be moved, rotated in every angle. Am I right? Okay. So translation, we have transformation in 2 different angles. When it is rigid or Euclidean, we'll have 3. The mathematical expression is given here, the matrix form is given here. We'll see this in depth. Okay. I, R, similarity, affine, projection. So here you change or it preserves the orientation, changes the other, it preserves the length, it preserves the angle. In affine, it preserves the parallelism. Okay, when 2 objects are parallel, the parallel remains same before and after the transformation of an image. Okay, so here when I say this preserves, this thing now, this preserves, this thing means that what does not change in the image from a pre-transformation stage to the post-transformation stage. That means you are transforming an image before what is the condition, after what is the condition. These are the 2 things that you are going to analyze. Before what is the condition, from after what is the condition, these things will not change in these kind of transformations. So we look into the first translation. In translation, we can write the transformed matrix x dash of t. When I say it is x dash of t, it is the image matrix after the particular transformation is done. After translation is done, we have x plus t, or we have this in matrix form, x dash is equal to I is the identity matrix 2 cross 2 t into x bar. So We are translating an image from one form to other. We are translating this image. The output image is x dash, the input is x, and I stands for a 2 cross 2 identity matrix. So the first transformation, what we have learned, is called as translation, where the output is simply an addition. The next type of transformation what we are going to study is rotation plus translation. It's called as Euclidean or rigid. Okay. It's also known as 2D rigid body motion or Euclidean, and it can be written as x dash plus r into x plus t. So here this r makes this difference. This r makes the difference because you are rotating this image by an angle theta. So the R matrix is represented as cos theta minus sin theta, cos theta. Euclidean transformation is also known as rigid body motion or 2D Euclidean. That means rotation plus transformation. Mathematically, it can be written as x dash is equal to rx plus t. And R is an orthonormal matrix. That means the determinant of matrix R, determinant is 1, and R into R T, RT means R transpose, will be an identity matrix. Shall we proceed to the next type of transformation? The next type of transformation is called as scaled rotation. Scale rotation, in the first diagram I showed you how these transformations are happening, right? Do you remember that image? It's also known as similarity transform. It is represented as you have an additional factor called as S, where you scale. You define the change in translation at particular values. This S is the scaling factor, or is known as the arbitrary scale factor. So the output x dash can be written as S RT, a row vector, into x bar. Here we don't require this kind of a square plus b square is equal to 1. So similarity transform preserves angles between lines. Very important objective questions. You can get this kind of questions in your assignments also. Okay, I'll be posting your first assignment in your Google Classroom very shortly. This assignment is your internal mark component, and the internal marks will be calculated on this behalf. So now I can give an example of a question. Similarity transform preserves first one angles, two parallel, third, fourth, like that. You have to choose the right answer, right? So in that case, you will have to choose angles between the lines. What is meant by scale rotation? Understood, all of you? What is meant by affine transformation? What is affine transformation? In this, A is an arbitrary 2 cross 3 matrix, and the transformed matrix X dash is given as a matrix. This is A matrix. A0, 0, 0, 1, 0, 2, 1, 0. This is a matrix. This is an arbitrary matrix. Okay. Now, this kind of 2 cross 3 matrix is used because in affine transformation, we wanted to maintain the parallel lines as parallel itself even after the transformation. The parallel lines remain parallel even after the transformation. This kind of transformation is called as affine transformation. Shall I proceed? Next, and the last type of transformation that we are going to see is known as projective transformation. It's also known as perspective transformation. It's also known as perspective transform homography, and it operates on homogeneous coordinates. So it is very easy for you to remember when it comes to homogeneous coordinates, it stands for H. Okay. In the first table which I showed you, wherein you have all the transformations and the related matrices, okay, in that you have this orientation and what is being preserved. Here we have a H matrix which is an arbitrary 3 cross 3 matrix, and H is an homogeneous matrix defined only up to a scale, and that two H matrices that differ only by a scale are equivalent. Okay? So this is how the transformed matrix looks like. X dash, you'll have the values. This matrix will have something like this. H00, H01, H02, and so on. Now, in the coming class or in the coming sessions, I will explain to you how these projections or how these transformations will look when you see an image. What you understand from that, really what this transformation means. Okay. So initially, to begin with, I wanted you to have the mathematical and theoretical understanding of what are the different types of transformations that we need to study, the basic transformations. And what I have taught you today is purely in the examination point of view, and you may get questions based on this. Your assignments or your quiz or all these things are being done only through this. Okay. So in perspective transformations, straight lines are preserved from the original image to the transformed image. So shall we wind up this session? If any questions to be asked, you can ask. See, there is a difference between your regular subjects and elective subjects. Elective subjects, you should be more interested. Okay, it will give you more energy. And as I told you, this will help you to do your projects a lot. And all the fundamental things should be prepared and studied well by you. So you can come out with your questions or doubts or queries, anything of that sort, which can be sorted out right now. If you have not completed any of these portions in the notes, always you can refer to my notes. I will try to post as much as possible, both in PDF format as well as in videos. Video format is for sure available, and PDF formats are also available. The questions for this is exclusively framed, and all your tests and everything, assignments, everything will come only through Google Classrooms. So any queries? So thank you all. Thank you very much.